Hey everybody, welcome to our miniature webinar, Binary Logistic Regression, the rock star of regression. I am William O. Bannon of StatsWhisper Incorporated. As always, feel free to visit us on the web at www.statswhisper.com. Now, at StatsWhisper, we strive our best to make data analysis and statistics clear and doable and fun. Not necessarily in that order. Sometimes if you make it fun first, it becomes clear and doable a lot faster. So pay attention tonight and see which one we make first and see how your learning goes. Okay, so the goal of the webinar here is first we're going to do our presentation on binary logistic regression. Then we're going to mention the 5-week webinar from which the presentation was taken from. Now, I guess anybody who read that title would say, why the rock star? Why is binary logistic regression the rock star of all regression models? I mean, hey, they're all pretty cool, right? So anyway, binary logistic regression produces what's known as an odds ratio. The odds ratio is just about the most widely used and understood statistic in the world. So, for example, if somebody says, if you eat fruit, you're 10 times more likely to be able to jump over a building in a single bound, right? Everyone understands what 10 times more likely means, right? So it's a statistic that people understand, even who don't know anything about statistics. A lot of the times, people who know statistics don't understand what statistics mean, right? So that's why it's the rock star, because it's widely known and because it's so simple, conceptually, it's widely loved, right? So when you consider that the nature of the other statistical methods used, it's really the rock star. It's the most loved and famous. Now, why do researchers love binary logistic regression? Well, for one thing, one good odds ratio can make you famous. Just imagine if you were the researcher that discovered that if you ate like an apple, an orange, and a pear consecutively, and you could leap over tall buildings because of it, you'd be very famous, and they'd probably quote your odds ratio. Professor so-and-so discovered if you eat these 3 fruit in a progression, you have these superpowers, right? 10 times more likely to have these superpowers, and that would do wonders for your career, I would imagine. Now, the other thing that's even more practical, right? How often do you come up with an odds ratio that everyone repeats, right? Maybe not so often, but this is quite common. Here, the binary logistic regression does not have the strict assumptions that some other regression models have, such as linear regression. Linear regression, you need tests of heteroscedasticity and normal distributions is the big assumption that's often violated. Often people forget to even look at it, but you have to make sure that there's a normal distribution in your linear regression continuous variables, or else it's not appropriate for the analysis. And if you've ever done this and found you don't have a normal distribution in your variable, and you have to account for it or do a transformation or remove outliers, you know that it's a lot of work, and it can even be frustrating. So when you do logistic regression, you don't need to do that, and that could save you a lot of time and frustration. Plus these, pardon me, these odds ratios, they're more definitive, right? So if I say that if you eat fruit, that there's a greater association between eating fruit and being able to jump over a building, right? The magnitude is not reflected, right? Is it you're a little better qualified to jump over that building or a lot? But if it's an odds ratio and you say 10 times, immediately you're conveying a measure of magnitude where you're saying that if you do this, you're this many times more likely to do that. So it's a lot clearer and more distinctive. So binary logistic regression, when would you use such a procedure? You would use binary logistic regression when you have a dependent variable, right? The variable you're studying, right? Dependent variable that has two categories, or sometimes we shorten it and say two categories, right? Such as yes or no, right? So if you're predicting, can you jump over a building, yes or no, you would use binary logistic regression. Any yes or no outcome that you're examining. So two cats, such as yes or no, and to help remember that, we actually have two cats here, one named yes and one named no. So just remember the more asinine the mnemonic, the more likely you are to remember it for a long time. So this one, you might remember it for the rest of your life. Okay, so what are we doing tonight with this binary logistic regression? Well, this is our plan. First, we're going to identify some study variables, right? We need some variables to study before we can examine them. 2, we'll prepare those variables for analysis, right? That's often the biggest part of the work. And then 3, we will perform the statistical analysis. So we'll do the binary logistic regression with our variables after they're prepared. Okay. So if we're looking for our study variables, of course, we need to identify a dependent variable, which is the variable we're explaining, right? And then we need some independent variables, the variables that will, explain our variable of interest. Now, a lot of the time I like to select a lighter topic for analysis, because I find if we start studying depression in statistical analysis, I start thinking about depression and being depressed rather than the statistical procedures, and the same with any other sort of outcome. I think about the construct rather than the procedures, and I like to project that onto other people and think they think that too. So I like to select a nice light topic to study. So in the movie What About Bob from 1991, this is Bob in the upper right-hand corner. If you've seen the movie, he was walking down the streets of Manhattan saying, I feel good, I feel great, I feel wonderful, right? And he goes to a psychiatrist's office, and this was the interaction. So Bob says that there are two types of people in this world, those who like Neil Diamond and those who don't. My ex-wife loves him. He's explaining reasons for his divorce. So his psychiatrist retorted, I see. So what you're saying is that even though you are an almost paralyzed multiphobic personality who is in a constant state of panic, your wife did not leave you. You left her because she liked Neil Diamond, right? So what if Bob is right? What if there are two types of people in the world, the ones that like Neil Diamond and don't? Well, it would be kind of interesting to be able to predict what's associated with liking Neil Diamond or not liking Neil Diamond, right? Most of us have had that, like a famous actor or comedian, and we say, I wonder why people like that actor or comedian. Well, here's your chance to find out, right? You're going to do an analysis to see what's associated with liking Neil Diamond or not liking Neil Diamond. So that's our dependent variable, right? Two categories, yes, no, do you like Neil Diamond? Now, this could be another question of clinical significance, right? So if we're looking at the flu, rather than do you like Neil Diamond, yes or no, it could very well be, did somebody contract the flu, yes or no? Did someone indicate patient satisfaction, yes or no? Did someone recover from depression, yes or no? It could be anything. Just in this case, it's do you like Neil Diamond, yes or no?